to dive into the last part, which is the practical part, we can start with speak about iOS security tools like CryptoKit, like Secure Enclave, etc. that we will discover later in the practical part. Before we dive
Sure.
into the practical part, we need maybe to introduce this framework for people that watch us before the practical part.
Okay,
Yes.
so the first thing that to realize is that on the iPhones, there's a hardware accelerated encryption and there's software encryption. The two of them will be major different. When you go on hardware accelerated, it can run sometimes 1,000 times faster than a software solution. So when you do AES encryption or when you pick your encryption algorithm, always go in the documentation and pick an algorithm that is hardware accelerated, because it will run a lot faster and the impact on your user will sometimes be visible. Like it can be the difference between a document opening almost instantly versus a document taking 20, 30, 40 seconds to open. So always pick an algorithm that is hardware accelerated. Second thing is understanding file system protection and encryption. There's file protection mode complete that we talked about that you can enable. Sometimes like file protection on complete until first unlock. Sometimes it's like when passcode or when unlocked, and there's different modes that you can select for your protection mode for your file, but none of them get actually applied if there's no passcode on the device. So understanding the limitation of what you're using from the file system, extremely important. There's Touch ID, Face ID. Yes. A lot of time people think Touch ID and Face ID does some magic. All it does is ask if the finger that the user is going to put on the device is authorized to have access to the device. Is it the device owner? You don't know. The user could authorize his daughter to unlock his phone with his thumb, or his wife, or his coworkers, or his friends. Yes. You can have up to 10 fingers, I believe, on the phone to unlock your device. It doesn't need to be the same 10 fingers of the same person. It's just 10 fingers. Same thing for faces. Apple allows you to scan faces, multiple faces, to unlock with Face ID, in case you have glasses one day, or it's your wife. So you can have Face ID that completely different faces unlock the same phone. So when you are asking Face ID to validate the user, you're not asking to confirm that it is the current user that set up the account. You're just saying, is it one of the many authorized users that is on the device? So always be worried when you do Touch ID and Face ID authentication to understand that limitation. There's a Secure Enclave. Secure Enclave is one of the most awesome thing that you can have on a phone, because it's a security hardware chip that is directly built into the hardware of the phone. If the replacement phone, the chip is no longer the same. So you can detect that and you can verify that. And that means if your data that is on your phone requires a Secure Enclave private key, and the data is taken, installed on another phone, and they want to use it from that other phone, they won't be able to use it because they need that private key that only matches that one hardware device. So it makes your data a lot safer, because you need that specific hardware with that specific data in order to be able to do anything. So it increases the security level significantly. You're no longer worried about your data moving to another device or being exfiltrated or going out in the cloud. As long as you're encrypting with that private key that is in the Secure Enclave, your data is secure. And the private key, that's another thing that I did not understand until very recently. The private key that Secure Enclave generates, it generates the private key, then encrypts it, and gives you the encrypted key, and you can store it anywhere you want. You can store it in the file system. You can store it into the keychain. You can even send it to the cloud and get it back later. But the private key is encrypted, so you are not able to use it until it's back on the same hardware that generated on that same A2 chip that generated that private key, or that same Secure Enclave. And then the Secure Enclave will be able to decrypt it and then use it. And the decryption key is unique to that specific chip. So every chip, every Secure Enclave device has their own unique encryption. So when they generate that private key and they encrypt it and then give it to your app or into the keychain or wherever they store it, it's unique to that device, because, again, that encryption key is baked into the hardware of the phone. So Secure Enclave, absolutely gorgeous little piece of hardware that is available, and you can use it with CryptoKit to generate like a P256 electric curve cryptographic key pair. That's a mouthful to say,
Okay.
but it actually just generates like a public and a private key pair. And using the private key, you can sign your data, and with the public key, you can validate that the data was signed with the private key.
Asymmetric encryption. Yes.
It's like it's yeah, you have both encryption and cryptographic signing.
Yes.
They serve different purposes. The cryptographic signing will verify that the data is authentic.
Mm.
The encryption will make sure that the data is not readable.
Okay.
So one verifies that the data is not modified; it is intact, while the other one actually hides the data from you. So
Okay.
encryption hides, and cryptographic signing will only confirm that the data is authentic and has not been modified and actually comes from the person you expect it to come from.
Yes.
There's the keychain service that you all mentioned a few times, where it's a secure hardware, it's a secure store where you can store secrets and small data packets. It's not recommended to store all of your files and large files in there, but you could, but it's not recommended. But the keychain normally is used for storing secrets and whatnot. But again, like as we mentioned, if there's no passcode on the device, it's just a data store. If there is a passcode, then it becomes encrypted with the ES256. And then there are file system permissions that you can set on each of your file to make sure that these files are not included in the backup. Because sometimes you want to be able to create files that if a user makes a backup, that file doesn't get on the backup at all. You don't want that. Okay. So that allows you to set those kinds of permissions for the files to exclude files from backup. So CryptoKit, Touch ID, Face ID, Secure Enclave, hardware acceleration, file system protection, keychain cross control. The only one I missed is the App Store receipt validation. Kind of touched it before with device check. There's a framework called device check that allows you to get an app attestation that confirms that the app was installed from the real App Store on a real device. So with the app attestation, you can again send that to your server and get confirmation that it was indeed coming from Apple. And then allows you to also confirm that you're running on a real physical device and not a live container from a hacker.
Yes. Great. We have this introduction that, from my point of view, it's important to go after that to the practical part. And I think that we can go to the practical part now. Because,
all right. Let me share my screen then.
Okay.
So I prepared this little Security 101 app last night. Had fun with that. My wife was like, forget the drink.
Okay.
Anyway, so I had quite a bit of fun. What I have is 5 levels of security and 1 level of extra validation for the front end. And it basically we're time traveling to the 70s, 60s, all the way till now to kind of see what was done in our understanding of server-client communication and what we did over time. So when everything started, the Linux servers had a /user table or where you were able to store all the users, and then you had a password table where everything was there, but the passwords were just like they're readable in plain text. And then we were also able to create some HTTP user authentication tables, but they were again all in plain text, readable. We were even creating SQL databases with username and passwords in plain text. This is an example here. So on my server, I have an authorized user. His username is xcrypto and his password is let me in.
Okay.
So we're going to connect from the mobile app here, and I'm going to say xcrypto, and we're just going to try a different password. And it says access denied. We can see the request coming in. And we have that concept of man in the middle here, where we can see it's somehow in the network somewhere, it's able to capture the data coming through. It may be broken HTTPS, maybe it's the admin sitting on the server there, snooping on the request, maybe it's the firewall, I don't know, but it's able to snoop somewhere on our communication.
Okay. So
here we type xcrypto, we say duh, and we can see there's a JSON request or a package here that is there. It says username xcrypto, password duh, and then we see that the server denied access. Obviously, if we try to if the man in the middle tried to use that, it didn't work. So obviously if they try to use it, it's not going to work either. And then if we log in with the password that is expected, because we can see it in our database here, it says, perfect, we're signed in, access granted, and we can see the request here. Now the user can sign out. But now the man in the middle, because he was able to capture the request, they can also sign in.
Okay, this is the problem.
And they can sign out. And
Yes.
the thing, somehow via a backup that leaked to the web or a hacker that got into our database, they make a database dump, they're going to be able to see all the username and passwords of every single user, and then they can just type in the user, copy paste the password, and just say let me in, and they're in again. So this was like back in the day when we were stupid. Some people still are noob. They got no idea. They created a database with username and password, and they think they're smart. Don't do that ever, please. But if you do that, then that opens you up to those kinds of attack. Both a man in the middle be able to capture, because now the man in the middle here, he knows what your password is. Not only can he log into the system, he knows what your password is. And if you're reading that password to other systems, he may be able to sign into your bank account or to your Facebook or Instagram. So password reuse is bad, but if you do use the same password, now the hacker has it. So this is exactly what you don't want to happen. So when there's database leak with all the username and passwords, all of those users are compromised in one shot across all of their potential platforms. So we really don't want that. So this is where we go to just bumping up the security a little bit.
Yes.
Eventually, what we started doing is storing hashes of password. We talked about cryptographic hashes before, where we take some kind of text and we get a numerical identifier of some kind or that represents the password, but it's not the password. So you can't get it out of it. So in the server here, this is what we've done. So now we store the username, but the password, we store the hash instead of the password itself.
It's hashable, yes.
So if the database is leaked, the hackers can't possibly know what the passwords are. So let's see what happens in that system. So we're here, we say let me in, and we haven't modified the communication. The hacker in between, he still gets the password along the way, but now on the server, we receive the request that says let me in. We compute the hash of that password, and then we compare to make sure that the hash that we computed from here is a match to this. So we're still able to validate the access. And if we try to use different password, something else, we get access denied. So clearly the server is able, by storing a hash, to be able to compare it, which is great. At least if the database gets leaked, the passwords don't get leaked. But if there's a man in the middle, we're still pooch.
Yes. There is no... it's not convenient because it's not important from my the point of view that we have the hashable, but the men in the middle, they detect, they have the information that comes from the client, and they can contact the server. We secure, we try to think that we secure the communication, but really there is no security.
Well, it did improve one thing. If there's a leak of the database, not all of your user accounts are compromised.
Okay, I understand. Okay.
We solved something. We solved the problem of the database going to the cloud.
Yes. I understand.
So now we're gonna amp up a little bit. We're gonna try to be smart. So what we're gonna do now is, instead of sending the actual password to the database, because the database is storing the hash, so instead of sending the password, we're gonna send the hash ourselves, right?
Okay.
So scripto, let me in. Now we can see that the man in the middle captured something, which is the hash. So now the man in the middle can no longer know what the password is.
Okay.
And the database receives the request. They're able to compare the request with the password in the database. They're like, yep, that's the same, and allow you in.
Yes, it's much better.
Is it? Well, now the hacker can just send the same request with the same hash and get signed in. They don't know what the password is. It doesn't matter. They can send the same hash again to the server and get this.
Yes.
Solve one of the problem. The hacker can no longer know what the actual password is. But we didn't resolve the issue because the hacker can still get in.
Yes.
So how can we solve this? And then this was solved back in the 80s there was a protocol called POP3 for email client.
Okay.
And that protocol was working on there was no HTTPS back in the day. It was just like TCP.
Yes.
And you were talking straight to the server, and people could snoop in between, and they figured out there was a way with a man in the middle to securely exchange and verify password. And this was called a challenge. So when you first establish the communication, the server gives you a challenge, and then you, with that challenge and the password, you compute a hash. You send the hash to the server. The server will be able to validate that the hash is a match. This is what we're doing here in level 3. And this, because you give them a different challenge every time, the hash that the client has to reply back is different every time.
Okay.
So there's no replay attack that is possible because the challenge will be different. So this depends on a few things. First, the challenge has to be different every time, so it has to be unique. It has to be unique only once, so meaning you generate it, it's valid only once, so you do one attempt, and if that one attempt is used and consumed, it's gone, because otherwise the replay attack is still possible. So this is what we're doing here.
Okay.
So we're going to create a sign-in request. We're going to connect and ask for a challenge. So now we get ourselves a challenge, and we enter the password. Let me in.
Okay.
So we get the challenge. So here in the authentication request, we provide the challenge that we have received, the ID of the challenge, and we provide our response to the challenge.
Okay.
And let's see here. What did I do? Oh, uppercase. Right, challenge, uppercase. So I did that demo specifically for the purpose. The challenge is only valid once. So if I do here, you see my challenge is changing, right? So if I sign in once, it works. If I try to sign in again, it no longer works because the challenge that I is only valid once. And this is exactly why I had to request another challenge in order to be able to sign in. But this is also what's going to protect us from a replay attack from the man in the middle. Now, if the man in the middle gets this, he tries to replay, access denied. The challenge is no longer valid, and he's not sign in.
Okay.
So this allows us to protect the database. Now the database no longer has the password, so you can't figure out what my password is. And this challenge here is unique every time. So we think we're safe, right? This is much better than we had.
Yes.
Now, what happens if the database here gets leaked?
Okay.
The hashes, the server doesn't know what our actual password is. They just have the hash.
Yes.
So how can the server then verify whether or not we know the password? Well, obviously the client here, the way it works is that first we compute the hash so that we have the same information that on the server, and then the server will generate a challenge and will only be able to compute the expected response based on the hash and the challenge. Never the original password, because it doesn't have the original password. So over here, this is what we're doing in the code. We are acquiring a challenge, and when we have the password here, we first compute the hash of that password. Then using the hash and the challenge, we send the response.
But we are dependent of this challenge.
We are dependent on the challenge, but if a hacker gets hold of the database hash, now here's what's going to happen. He's going to enter the username, request a challenge, and he can request challenges as often as he wants.
Okay.
And now he has the hash, and he can sign in.
Okay.
So we did improve a few things. I mean, if a hacker is in the middle, he will not be able to just replay the attack and sign in. Great. The hacker doesn't know what the actual password is. Great. If there's a database leak, they don't know what the actual password is.
Yes.
They can still generate their own challenges and they can still sign in. So a database leak is bad, not as bad as before, because at least they don't get the actual password of the users, but it's bad in our own infrastructure because the hashes can be used to sign in.
Okay, great.
But at least it doesn't affect the other services. Like, let's say I'm running Facebook and my Facebook database gets compromised. My users that are on Amazon or on Apple, their passwords are not compromised because my own database is compromised. I can just wipe my database, change the salt in my database, generate a brand new salt, a brand new hashes for every user, ask all the users to reset their password, which we've seen in the past, people saying, hey, you need to reset your password, we've been hacked. So when that happens, you reset your own database, you ask your user to that, but at least it affects only your server, your account. It doesn't affect other services. So we solved a couple of issues, but we still haven't solved that one issue that if the database gets leaked, the hacker can sign in into everything else. This is where we go to the next level.
Level 4.
Level 4. So here we're saying, you know what, those damn passwords, they're a problem. I no longer want them. So instead of doing password-based cryptography or password-based authentication, we're going to go to a system called passwordless. Like, how can I authenticate securely to a server if I don't use a password? Like, what the hell?
Yes.
Well, public-private key cryptography is a mathematical system that was designed in the 1970. And since the 1970, it has survived every possible attack that tries to make it break. As long as you have those private and those public key and you use the proper algorithms, you can generate a secret that you never share to anyone. Then you generate something that you can give them called a public key, and you can share that on your web. You can post it on your front door. You can give it to anyone that asks it. It's public. You no longer give a crap. You give that stuff to everyone. And you want to publicly make it super easy for people to figure out what is Walid's public key or what is my public key. You want people to easily be able to compare and verify that it is indeed your public key. There are public key repositories publicly available on the internet. So you want that. But your private key, you keep that secret. You never share that to anyone. But once you have your private key with your public key, what you can do is you can sign. So you have a piece of information that you're able to sign with your private key, and anyone that has the public key is able to verify that this indeed comes from you, or someone that has a private key at the very least. So you're able to confirm that this request or this bit of data is validated, cryptographically signed from the person that holds that private key, and assuming that private key is only held by the actual. That means that you're able to now confirm that the sign-in request does indeed come from Walid. So we're going to first generate a private public key pair. So obviously the private key is private. I'm not going to give it to you. And then the public key I'm sharing. It's right here, public key. And then what I'm going to do is I first install my app on the device. I ask the secure enclave to generate a private key. So the secure enclave, directly baked with the hardware, generates a private key that I can use. And then it gives from the public key, from the private key, I can get the public key. Great. Now I know that I have an identifier that is unique to my app installed on that device. Only that device. So assuming that I can use that, that should be authentication enough. So now I'm going to ask the user to register. So I'm going to create an account for that user. I'm going to call him Walid. So I'm going to create an account for you, Walid, using the private key that I have on my system. And then obviously during the registration process, usually you will also have an email address that is there, and you would send an email to the user asking
confirmation
that it is their account. But once that confirmation is done, I can take the public key that you're going to send to the server, record it into my database, and now I know that this public key matches the private key that you personally own on your device.
And it is secure because
we have secure. So
enclave.
I do that. Exactly. It's protected by the secure enclave on the device. And if someone steals your device, change and do a factory reset, that key is gone because it's gone. If you get a replacement device like another phone on the same account, unless you authenticate that you're gone, so we need to revalidate your identity. So this is how Telegram works. Telegram generates a private key on your phone, and this is why it's so secure. And this is why the authorities are putting Rav in prison right now. It's because the system is so secure that unless you have that physical phone and access to unlock the secure enclave, you ain't getting into the Telegram account, my friend. It's locked solid.
Yes. Okay.
So this is what's happening here. We are basically creating an account. Now my server knows that Walid has that public key, and only Walid can sign in. And all Walid needs to do now is make a request. No
Okay.
password required. Walid can sign in, sign
It's
out
come.
as often as he wants without entering any details whatsoever. It's much more convenient for you to sign in because every time you open the app, you can sign in automatically. And every time the
Okay.
app goes to background, you can sign out or keep the or whatever you want to do. But you can make it very secure, very fast, and no user interaction required because you have unlocked the device. So clearly you have access to the device. You have the physical device with you, and that's the right physical device for unlocking the private key. So there we go, safe. And now
Okay.
if a hacker tries to use this, attempt denied because they don't have the private key. They cannot generate a request for wallet that is valid because they don't have your private key. So now
Yes.
in a system like this, if the database gets leaked, I don't care because it's all public keys anyway.
Yes.
So at worst, you're gonna have a list of all the username that are on the system. And the public keys,
Mm.
fine, they're public. I can post it in my front door and it's no problem.
Okay.
And I have my private, and then the user, super easy to sign in and out. It's called passwordless because there's no password to enter. And
It's
then
great.
there we go. So this is the strongest system that exists right now that we're using. Obviously, you can also include, if you want, a hardware keychain that generates one-time passwords and one-time keys and whatnot. You can integrate with that. But as far as like authentication with just like with a server and a client, this is as strong as it gets because you need the physical hardware. It's protected by the secure enclave. You generate a private key, and this is it.
Yes. Great. Great. But we didn't spend level 5 because we are satisfied with level 4 now.
Well,
But
level 4 is great. It secured all of the communication between the client and the server, and this is what we wanted. We also secured the database in case it gets leaked. So it's secure a lot of the basic infrastructure.
mm,
Uh, in level 5, I want to focus more on the client side. What can we do on the client side to make things
okay.
during the authentication process? And one of the first thing is when you create a username, very often the servers restrict how many characters you're allowed, which characters you're allowed. And so many times I open the source code of an app and the username is just a string. And you're
Okay.
like, dude, what the hell are you doing? Like if I'm creating a username and it has a bunch of requirements about length, minimum length, maximum length, allowed password, and then in the app itself, you just store a string. What's the guarantee as a software developer that every time I'm referring to making a reference to the username, that it will actually respect all those criteria? Because it's just a string. If you have a bug in your code or if you mishandle the like reload, let's say you save the username on disk, then you reload from disk or load it back from keychain, is it still
Okay.
valid? Because you stored it as a string, you read it back as a string, then suddenly the data that you read back from the disk was modified by a hacker, and your username that was originally 20 characters long is now, guess what, 12
Okay.
megabytes long. And it happens to be an attack for the server because when you're going to send a 12 megabyte username to the
Mm,
server, it's going to create a buffer overflow on the server, and you got to
okay.
take control of the infrastructure.
Mm. Ah,
So
okay.
these
Okay.
kinds of
Okay.
attack are become possible if you don't do proper software development. So in order to
Okay.
the authentication from the mobile app, you first create a username data type, and then during the only way to create that username data type is to provide a valid value, right number of characters, the only valid characters, and all everything required.
Okay.
So this is what we're doing here. So if we just type E, well, it's too short. Uh, and as soon as we have the 4 characters, it becomes valid. And then if for whatever reason it's too long, it also tells us it's too long.
Okay.
And if we try to use a character that is invalid, it tells us.
Okay.
So the username class that I created here validates the allowed characters, the minimum length, maximum length, and it tells us. So as a user, as I'm creating everything, I have validation. But this isn't just UI validation. My entire data type username is actually implementing those validations.
Okay.
So I'm just going to try to come up with the code here. I think it's somewhere on my machine.
Okay.
Uh, security 101. So this is the code that I have for this class.
Okay.
It's not that big. It's 47 lines for doing all of that, which I think is a fairly good deal.
Okay.
So the first thing that I do is I define what my value is. Well, internally, it's going to be a string, clearly.
Okay.
And I need to, when I create a new instance of that username, I need to validate it. So the first thing I do is I'm creating a static function that will validate the value, and that can be used by anyone. So any place in the code. So if I have somewhere in anywhere in the code, I want to validate if I can or not create a username from it, I can call
Okay.
it the validated function, and it's gonna validate all the criteria and return a valid, like the string, or throw an error if it's not valid.
Okay.
Now I can use this for quickly validating anywhere in my app whether or not the string being entered is valid, and I do that in my validated username here. Every time the username changes, I try to validate it. And then if it's not valid, I display it on the screen. So I have a Swift view here, and
Okay.
this is where you're entering the digits in the app. So every time I type in here, this is the code that gets run. It just runs the validate username validated. And if it
Okay.
throws an error, I know it's invalid. If it doesn't throw an error, it's good to go.
Okay. Great.
So I made myself a small Swift UI component that automatically runs the validation logic, and all the validation logic is in here, usable from anywhere in the app from any classes. And then the only thing that are important is when I create an instance of that class, I make sure to run the validator. If it's
Okay.
not valid, I'm gonna throw. And if I decode from
Mm.
a value that comes from a JSON response, or if I
Okay.
load it from disk or anywhere, I also need to validate it. So I
Okay.
create a custom decoder, and
Okay.
that's going to load my value, try to validate it, and then actually assign it only if it is valid. So now
Okay.
if
Great.
I try to read it, it's guaranteed to be valid. And now because if I don't want to have complex data structure, like I don't actually want to create like a request going to the server with like a user and then a value dictionary. Like I actually want to send just a string as the username in my JSON request, right? I don't want to send the username struct. I want to send the value of the username. So I do that via a custom encoder. So I create a custom encoder here, and I say encoder single value container, and I store the value of my string in that container. So that acts exactly like when you create a JSON or when you encode on disk. This works exactly like if you had a string. The same
Okay.
way, there's no difference in how the JSON is going to look in the end, but inside of my app, as soon as I load the username from anywhere, I decode it, initialize it, it's always guaranteed to be validated according to constraints. So anywhere now that I see a username data type, I'm guaranteed 100% that the string value is always within parameters.
Okay. Great. Great.
So by
Uh,
doing that, it allows you from a software perspective to kind of like provide some guarantee that your authentication process cannot be kind of bypassed or hijacked or replaced.
mhm. I think that people, when they see the man in the middle, how things how we can simulate using this kind of application, how enclave, especially using the system, using the secure enclave, and to bypass what we call using the password, etc. But there is a lot of things that they try to understand. Thank you, Dave, for this practical. I think for my point of view, I learn a lot about this. We will have others practical session about how we code using insecure mode. What we shared, you shared now, it's a small part
Yes,
of
a very tiny part of a big world of cryptography and
yes,
security.
yes. Okay, thank you. This is my last question before we finish. It's about your advices for developers that they try to start with security, etc. What kind of advices that you can give to them? First of all, for me, because I'm now very passionate about security, and a lot of my friends they try to begin in iOS security, especially when they are follow you in LinkedIn or in in Medium, etc. In every
Yeah.
social media that you shared using article, etc. What kind of really advices to start with security in iOS, especially?
Well, the first advice is you need to understand that this is an ongoing forever activity. Security is
Okay.
always evolving. So if you just assume that you're gonna learn it in a week and then be done, forget it. It's a lifelong thing that's gonna be like always.
Okay.
You have new things coming up, new ways of doing things. Like just a few years ago, zero trust architecture was nothing that we knew about. Just a few years ago, MD5 was still valid for hashing. Just a few years ago, we could use AES 128 for encrypting or like another encryption algorithm. Like encryption algorithm become deprecated, hashing algorithm become deprecated, architecture
Okay.
become deprecated, way of doing software changes. We're lucky now with Swift. We have a lot of built-in security stuff that Swift does automatically. So buffer overflows is almost impossible unless you really want to.
It's just,
Um, so there's a lot of things like that that the language itself supports that helps developers. But if you really want to do security, realizing that it's a lifelong journey
okay.
will really put you in the right mind frame because you need to be constantly on the lookout. You need to find sources of information that you can learn from and get new information. Like, for example, CVE. CVE is a database of vulnerabilities that get released. And
Okay.
so being on the lookout for any Apple CVEs and any of the CVEs affecting the frameworks that you're using. So you subscribe to the CVE notifications, and every time one vulnerability gets published
Mm-hmm.
by affecting one of your vendors, then at least you're aware of it. And then they also normally provide, along with the CVE, they will provide like a mitigation. How can you mitigate that issue?
Okay.
Sometimes they will just say, sorry, it's there. We have no fix for you. Just be
Okay.
aware. We're going to fix it someday. And sometimes it's like 6 years later. Oh, we finally decided to fix it.
Should accept that.
um, so, but being at least being aware that these issues exist at least allows you to make intelligent decision about what technology to use or how to deal with a specific thing. So, knowing that it's ongoing, and two, having sources of information that are constantly updated and keep you aware. That are the two most basic thing that you can do. Once you just follow that, automatically you're gonna be filled or provided with a lot of keywords, knowledge, forensic tools, and like some of those articles and news magazines about security, like Curbs on Security.
Okay.
When you start following them and read those articles, they mention like Ghidra and those tools, and you're like, "What the hell is Ghidra?" Well, do a Google search, find it, and study it.
Okay.
Or they talk about like man in the middle. What is man in the middle? Well, ask ChatGPT; is going to explain it to you.
Yes.
Uh, so just being on the look at having sources of information will already give you a lot of feed and knowledge and keywords that you can research on your own. So you have then it becomes to you. You have to be curious.
Okay.
Don't expect someone to spoon feed you all the security. You have to go and get it yourself.
Okay.
So be curious every time you see a terminology that you don't understand. Go and dig it out. What is NIST? What the hell is that thing eating at supper? What is OWASP? Well, Google it. Find what OWASP means. What is MASVS? Like, um, well, Google it out. You gotta find, and then eventually you build that encyclopedia of knowledge in your brain that you're gonna be able to discuss more and talk about it. So finding your sources of information and consulting them on a regular basis, like spending maybe half an hour every week is probably
Okay.
enough to get at least started on
Mm.
gaining that knowledge. And over time, you're gonna gain enough knowledge that you know what it's all about. Um, so that's my first advice: just
Okay.
get your source of information and consult them regularly.
And
Read them, and
consistently.
when there's something you don't understand, at least do a quick Google search to at least know what it means. Like zero
Okay.
trust architecture, fine. What does it eat? Oh, it just means that you don't trust anything.
Yes.
Okay, fine. I don't trust the API to be in the same security environment as my image processing pipeline. They are two completely separate services, so I need a way to be able to talk to this one securely, going through a potentially compromised network in between. Back in the day, when we were connecting to an enterprise via a VPN, as soon as we were past the VPN, everything was like free for all, open door policy. Nowadays, no longer allowed. Zero trust architecture means that every single machine that is within the VPN can be a hacker, or can have, or maybe a hacker is within that network. So as soon as you pass the VPN, you're no longer safe. Every machine that is on the network is considered a threat. So you need to consider every machine as not trusted, as a potential hacker, until it is trusted. So that's what we call zero trust. You don't trust anything, anywhere, ever, even if it is within your network. Once you build that mind frame, and you build those good habits of validating absolutely everything, validate, and triple validate, you're gonna have a much more safer environment to work with, and you're gonna build those tools. But again, you need good sources of information that are constantly updating you about new ways of doing things, and you need to be curious and learn them. Everything else is secondary.
Okay.
Because once you start going onto one source of information, it's probably at some point in one of the article mentioned something else, another source of information. And then you build your tool set over time. Everybody has a different tool set. We have some common website that we go to, but like the CVE, almost the entire industry that works in security monitors the CVE. But the thing also that you have to realize about CVEs, or public databases of vulnerabilities, is that manufacturers have an incentive to not declare a CVE as public until they have a fix. So if Apple has a security problem affecting Touch ID or Face ID, where an app developer, a hacker or whatever can bypass it, I don't know, you shake the device 5 times and then Face ID goes away. I don't know, like something stupid like that. Or you put the camera facing a mirror. I don't know if it's possible, but let's, if you find something weird that allows you to bypass Face ID, the camera faces itself and figures out, hey, I'm looking at myself, it's good to go. If there's a vulnerability like that exists on a device, Apple probably does not gain anything by telling you about it right away, because then the hackers will learn about it right away too. So they will try to keep it secret for as long as possible. Normally, there's a disclosure period of 3 months or 6 months. We call that a grace period. So when a hacker or someone declares to Apple or to Google that they found something, a security researcher, Apple asks for a grace period of 3 months or 6 months or a certain amount of time, where they ask the security researcher to not tell anyone about that shit until they have a certain amount of time to deal. And it's kind of like their contract with the security researcher. Thank you for telling us. We may even give you some financial compensation, but shut up about it. And then 3 months, we tell you that within 6 months, we're going to fix it. And it's contractual agreement. And in 6 months, if I haven't fixed it, you can go public with it. So 6 months down the road, or maybe 3 months down the road, or X number of time, Apple has a fix. And then they go and publicly declare that there's a security warning, a security issue. When the phone looks at the mirror, it will unlock itself. And then they declare that publicly, but they also have a fix. Please make sure that you update to the latest versions of iOS 18.0.1. And so users can immediately apply the security update, and it doesn't matter to them if they have done the update on their phone, they're safe. But if the security researcher makes a public announcement right away that this issue is there, and Apple hasn't had time to make a fix yet, and that becomes public, it's called a 0-day. And a 0-day attack means that the attack is out in the wild, being used, and there's no fix for it yet. So that's what we call a 0-day attack. And these things happen all the time, because sometimes the hackers find it before the security researchers. And they start using it. And then eventually Apple's like, oh my God, or Google or whoever the company is, like, this is being used. Let's fix it. And then that gets released. But so as long as you understand that the CVE, the database, does not mean that there's no other issues. It just means that those are the issues that they have publicly declared. So there's probably hundreds of security vulnerabilities in Google, in Apple, in Microsoft that we are not aware of, but that exist. So as long as you, in your mind, as a security person, you're aware of that, then you're good to go. You can look at the CV and say, oh, these are all the known issue, publicly known issue. There's dozens of others that we will learn about in the future. And so you always have to take a proactive approach with security, saying, okay, I cannot reliably say with confidence that these are the only issue I have to deal with, because they're known. There will be others. You just don't know about them yet.
Okay, great. Thank you, Dave, for all this advice, this practical session. Great thing about security. Hope that you find the podcast great. So the discussion with me, with the iOS developer that didn't have any knowledge about security, but they try using ChatGPT, use Google, etc., and so on to ask you some technical question. It's I know that I don't have knowledge about that, but I will try to. For me, it's a great episode to start to focus on security. Have some knowledge. I'm waiting for your book also with my. I make some advertising for your book, and I'm sure that we will buy the book to have the good understand and for security. There is not the last episode. We will have a practical episode with you about how coding in security manner, if you can say, some advices, some practical advices. In Swift Academy, we try to make a lot of practical things with our guests, because we think that we need in our community to have knowledge, to share knowledge about some good topics or great topics like security, because we need to share knowledge about that. And after that,
Talking about
yes,
sharing, I will try to share with you the Security 101 project that I created, so that
okay,
your
great,
honesty, your people watching the show can
thank you.
download it. Be aware, because I'm part of it is using a secure enclave. It means you're going to need a hardware like a computer that supports a secure enclave. So for those of you that still have Intel MacBooks,
Yes, should
you won't be
should
able to
in
run it.
M1, M2, etc.
M1,
The
M2, you should be
the silicon, yes,
or M3.
M3, etc.
Yeah, if you have a M-based laptop, you should be good to go.
M based.
But an Intel one, sorry guys. See you life.
Okay, great. Thank you, Dave, and see you soon. Thank you.
See you
Thank you.
online. Cheers.
Yes, thank you.